Question 6 is about two different topics. The first part is the binomial expansion, and actually for the second part we need to integrate. So two different skills tested here. For the binomial expansion then, we've got two terms and a power of 4. So you might be using this formula, a plus b to the power n. We don't actually need to find every term because we're given 4 out of the 5 terms, but just as a bit of an overview, remember we've got the sum from when r is 0 to n, so we'll always have one extra term than the value of n because we're also including 0 of n choose r. We'll just recap what that is in a minute. A to the power n minus r and b to the power r. So we are increasing our powers of b each time, and we're decreasing by 1 our powers of a each time. So just a reminder that nr is the binomial coefficient. It is also sometimes written as NCR. It's defined as n factorial over r factorial n minus r factorial. That's one way of finding it. The other way of finding the binomial coefficient is using Pascal's triangle. So Pascal's triangle looks like this. Sum of the two terms above each time. This would be the relevant line for this expansion, because when n is 4, we're going to have 5 terms, so we need 5 coefficients. We can see that the coefficient that we'd end up with for this term would be 4. The other numbers come from the values of a and b. All right, so for our fourth term here, let's define a and b. So a is 2x squared and b is negative 3. We are looking for the term in x squared, which means we're going to need 1 or 2x squared raised to the power 1, which means we'll need negative 3 raised to the power. Now these two, when we combine them, always give n. In this instance, n is 4, so this will be cubed. This also helps us figure out our value of r. So r is 1 in this, r is 3, I suppose here, but it's symmetrical, so r could be 3 or 1. So we've got r is 0, r is 1, r is 2, r is 3. So our value, the binomial coefficient, is going to be 4. Okay, this is 4 choose 3. So we know that's going to come out as 4 using Pascal's triangle. Or we could actually bung this into our calculator, or we could use the definition, like I've written there. So that comes out to be 4. Equally, you could say this is 4 choose 3. 4 choose 1. So we're going to expand this. This gives us 4. In the mark scheme, by the way, you get 1 mark for this, 1 mark for this, and 1 mark for this. Then we've got to expand this. We get 2 to the power 1 x squared, and then minus 3 cubed. 3 cubed is 27, so it's minus 27. You probably don't need a calculator here, but I would use one just to not make any mistakes. We've got 4 times 2 times 27. And then we've got the negative to take account of as well. And reading back the question, find the value of k. So we just want the coefficient of x squared. We don't want the x squared itself. So k is minus 216. You could expand the whole expression if you wanted also to double check that you were getting the other terms correct as well. But there's no need.